All right, so let's talk about some Python. So a critical and important part of your life going forward is, of course, lists. So let's go over some things that you can do with lists, with the subtle implications that in your homework number 2, you're going to be doing things that are very, very similar to what we're going over today. Maybe not all of them, but definitely some of them. So let's take a look at it and let's see how you would actually do it. All right, we're just a tiny bit of review here. Remember last time we talked about this? If you had a string that looked like catalog entry for a course, you had a title for the course and a 3 at the end. If you wanted to turn this into a list, the very first thing that you would do is put double quotes around each one of the strings. So this is the catalog entry. Now we put double quotes around the actual name of the course. And we'll do nothing with the 3, which is the number of credits, because it's a number, of course. Then we separate each one of the list items from each other with adding a comma. Add a comma there, and actually add a comma there. Fantastic, we're getting closer here. Then we surround the list of items with opening and closing square brackets. This is the important part from a Python point of view, because it tells it that this has now become a list. Okay, basically a collection of things. Okay, and in our very last step, we say take a variable over here, prerequisites, put equal, and then all of a sudden we've taken that list of things and we've assigned it to a variable. And once we do that, we're off and running. We can do almost anything we want with it. How to access a list? Once again, putting in a list is great, but if you can't get the stuff out, it's not going to do you any good. A list is simply a sequence of elements, which we have seen before. Each element, each of which has an integer position or an index. In other words, you can get access to each thing that's been put into a list. Remember, it doesn't matter if it's a string or a float or an integer. You're going to be able to reach into that list and pull out each individual item. To access a list element, you have to say, hey, which one do you want to talk about? I've got a collection of 15 things. What do you want? Well, I'd like item number 7. I would like item number 2. Okay? You do this by using, once again, the subscript operator, which is a fancy way of saying the square brackets. Okay? You use it the same way you use to access individual characters in a string. Remember, if we had a string that said, happy birthday to you, and we wanted to pull out the 7th character, we'd say string name, square bracket, and we would get 1 character back, right? So we've already used these square brackets before. You probably used it extensively in your homework number 1 when you were doing your encoding of the social security number and flipping the digits, okay? Here's an example, print values, square bracket 5, okay? Assume that values is a list that has at least 5 items in it. What we're going to do here is we're going to print item number 5, whatever that is, pop out. Make sense? Pretty straightforward. Just how we handle and interact with lists. Okay, if we want to append something to a list. So we have a list. Yay, fantastic. And we want to stick something onto it, add something to it. Okay, how do we go about doing that? Well, we would start with an empty list. Good food equals square bracket with nothing in between. Why would we ever do that? Well, one of the things that this does is it tells Python that in this particular case, good food is a list. Remember, in Python, there's no way to declare a variable. So the way Python figures out what type of variable something is by how you use it. So if we put a statement like this, and all of a sudden Python goes, okay, I got it, it's a list. That means every other action you're going to do to this variable is going to be a list type of variable, which is very important, especially if we're adding stuff to it. Because if we're adding stuff to it and it doesn't know what it is, it's going to get all confused. A new element can be appended to the end of the list with the append method. So we got good food dot append, and the word, the term for what append is in Python, we call it a method. So it's something that we use to modify a variable. We've got append, we put in double quote burgers. When we get done with this, the list good food is going to have 1 item in that list, and it's going to be what? Burgers, exactly. The size or length of the list increases after you call to it. Okay, any number of elements can be added to the list. So we can add ice cream, hot dogs, cakes, brownies, everything. Okay, just keep calling that append, and basically just sticking stuff on the end of the list. Keep it going, keep it going, keep it going. Make sense? I think I got some code to show you here. Probably no more code. should look familiar to you, maybe a little bit. So this is current year equals 2015. That's interesting. That's a very concept we're setting up. Oh my goodness. Where have you seen this before? Homework 2. So I copied it out of homework 2. I actually really copied it out of this, but in homework 2. But let's pretend I copied it out of homework 2 and I put it here. Okay? So you've seen this before. So patients, and it's a list of lists. It's a list of lists. List of lists. How many lists are in our list of lists? Turns out the answer is 15. There you go. Go figure. I think I can actually score.
How do you know my second dress?
Everything's on the web. So the very first thing we're going to do is just simply print out one of the patient records, just for kicks and grits, so we can sort of figure out where everything's at. Okay? We say patient ID is equal to 0. Okay, another constant. 4, index in range length of patient ID. Seems sort of complicated. What's going on there? So it's a for loop. Okay, we'll go with that. And obviously it's going to. But how many times are we going to do the for loop?
How many? What time are we on? The list in the list.
Okay, we're close. How many times are we going to do the for loop? Yeah, I'm trying to, it should hurt your brain a little bit, but not too much. So in that, we're saying we want to say the length. Okay, so we know what length is, that's cool. Length of what, though? So it's patience, which is good, because this is patience, right?
Yeah.
So is it going to be 15? Well, no, because we got some more stuff in there. What else do we have? Square bracket, patient ID. And what is the current value of patient ID?
0.
0. So what are we actually talking about there?
The very first.
So we're talking about Fred Johnson, aren't we? Or we're talking about Fred Johnson's record. Is that correct?
Yes.
Yeah.
So if we're going to do for index in range of length of Fred Johnson's record, is that what we're really saying there? So it's patients, square bracket, 0, square bracket, right? So length of Fred Johnson's record. Well, how long is Fred Johnson's record? Like 10 or 11, I think what it actually is. You can see it off the side of the screen. All right. So it sounds like we're going to go stepping through each item in Fred Johnson's healthcare record. That sound like a good deal? So what are we going to do? Print, index. Okay, that's our for loop variable, right? So what's that going to be the first time out? Next time out is going to be, after that is going to be, and then after that, patients, patient ID, square bracket, oh no, square bracket, index, square bracket. What's going on there? That looks really complicated. What are we doing? What's it going to print?
Oh, it's going to print the first entry of the first entry.
First entry of the first entry. So patient ID, and we know patient ID is 0. So who are we pointing to?
That's the Fred Johnson.
So that's Fred Johnson. So we're pointing there. So this first part, patient ID points here. But then we got some more. We've got index. First time through, you told me index is going to be what?
Well, it's going to be 0, which points to the first entry in that list.
So the first thing we should print is what? Johnson. And the next thing we should print is
Fred.
got it. You with me in what we're doing here? So listen to this. So this double index stuff allows us to go stepping through the Fred Johnson healthcare record. Go figure. That's pretty cool. Okay, so we know that Fred Johnson is 92 years old. I don't know how we know, so let's just go with that. Okay? So what we'd like to do is append his age to his healthcare record. Because his healthcare record, with all of its 10 items or whatever, does not currently have his age. So we'd like to take his age and stick it on the end of it. Excellent. How do we do that in Python? Why, look. Patients, square bracket 0. Whose record is 0? Dot append paren 92. So we're going to take the number 92, stick it on the end of Fred Johnson's healthcare record, rock and roll. Question in the back.
So does that put a comma at the end of the whole entire, like
There's
say
no-
it gives the information that says comma 92? Or,
So let me see if I can answer the question correctly. So the question is, does it put a comma when I'm appending the 92? Is that correct? And the answer is no. Okay, so I understand what you're saying. So the only time we'd ever see a comma is like if we printed it out and we printed a comma to separate the items. So there's no problem with that. But in the actual record itself, there is no comma. The 92 will just simply exist as a data item that's part of the list. No commas. Okay? Okay? If we ever printed it out and we printed them all together, it'd be a garbage. And then at the tail end would be 2 digits of 92. No commas separating anything. However, if we print it, and we remember to put commas between them, those will be commas. But as part of the actual record itself, no comma whatsoever. Does that answer the question? Okay. Then we have a little bit of code here, and coincidentally, this code is exactly the same as this code. Now, interesting point down here. For index in range, length, patient ID, which is 0 still. So what's going to go in there? What's that going to print out? Right. So basically, since this is the length of the Fred Johnson healthcare record, what does that mean? It used to be this long, but this time it's going to be what? A little bit longer, right? So we should print that out too, okay? All right. Well, this doesn't look like it's all that complex, because really, this is what we're doing. One freaking append statement, right? So let's see if this works. And there we go. All right, so we said we were going to print out Fred Johnson's healthcare record. Woo! How many items are there? You know, that's good. I'm good with that. You're exactly correct. That's a good point. But, and actually, I think I pointed this out to you last time. You might want to stick a little bit of code like this to print out one healthcare record at the start of your homework number 2, because it helps you remember, oh, date of birth is at what location? Age. Otherwise, you have to remember it in your head and count it out on paper, and sometimes you get a little bit off. And then things go downhill real quick. So just a little tip there. Okay, so we did that append thing, right? Now the second time, how many items are there in his healthcare record? 12, and what's the last one? 92. So we stuck it on the end, right? Append is the greatest thing. Well, that's not greatest thing, but it's a handy thing. Well, appending is great if you want to stick something on at the end of the list. That's fantastic. But sometimes you want to do something a little bit more sophisticated. Specifically, what you want to do is you want to insert an element. So you want to add something to a list, but where you add it is very important. Okay, not a big deal whatsoever. We got an insert command to do that. So if we had a list that said friends, Harry, Emily, Bob, and Carrie, okay? And what we wanted to do was insert the string Cindy into the list. We could do insert 1, starts with position, and Cindy. And that'll stick Cindy in where? So Harry's at location what? 0. Emily's at location what? 1. So we're going to take Cindy, stomp on Emily, right? What's that going to cause Emily to do? She's going to be pushed out, right? Can't really push back because 0 is 0, right? So if this is 1, Emily will go to 2. Yeah. And that's it. Okay. Index that the new element's going to be inserted at must be between 0 and the number of elements currently on the list. All right. So you could insert at 0, 1, 2, 3. You could insert at 4 because it doesn't have any freaking clue what you're talking about. All right. But if you do it, the number of elements on the list, then it sticks it at the end, which is pretty much the same as an append, right? So what this means is that you can insert something at the tail end of the list. You have full control over where you insert something.
What's the 2 included?
I think the leftover.
Should be leaving that for a little scrap, I should say.
All right, let's take a look. code, yay. All right, so we've seen this before, we know all about that. Now we're going to print out the contents of each list. Okay, cool. So we're going to print out just like we did before. That'll be what, 0 through 10, right? Insert the encrypted social security number into the patient record. Ooh, that smells like homework number 2, doesn't it? So patient 0 dot insert at location 9. What's that location 9?
You're going to get a bird, right? You get a bird.
What's that location 9? You are correct. It is right after date of birth. So we're going to squish it in there. So what's going to happen to the actual social security number? It's going to go to location 1? 10. That is correct. Location 9, we want to insert the secretly encoded social security number of star dash star dash 12. And then we're just going to print it out once again, and we'll have to take a look at the new one. So this is the one you found right here. Okay. Woohoo! All right, so this is the unadulterated list. Yay, fantastic. Then we went ahead and we did our insert, right? Specifically at location number 9, stuck it in, and what happened to everything that was at 9? It got pushed down. And now obviously we have 11 items in the list, whereas previously we only had 10. Poof, did exactly what we expected to do. Thank goodness, because otherwise that would have been problems. Well, okay, I'll just add pending and inserting stuff's fine, but what if I have a list, and I think something's on the list, but I'm not 100% certain? Well, I would like to find it. More importantly, I'd like to find what location it's at, right? Cool, and that's exactly what find is about. If Cindy in friends, hey, she's a friend, okay? If you want to know what location somebody's at, such as Harry, Emily, Bob, Perry, and Emily, you want to find out where Emily's at, you can say variable name equals friends.index and then the string that you're looking for. Find this in the list and tell me what location it's actually at. And oh, by the way, if it occurs more than once, then what you can do is you can say, start searching from this location. In other words, if I know where it's already at, don't bother with that. Now start searching from this location to the end. So you got a couple options there. Let's take a look at the code and see what's going on. Alright, we got all our standard source stuff up there, we printed out, okay about that. Okay, a couple of blank lines, okay about that. If Fred in patient 0, whose record is patient 0? Fred who? Fred Johnson. So should we find Fred there? Yeah, we should. Then print, I found Fred! Else print, I didn't find Fred. If Betty in patient 0, whose record is patient 0? Fred. Are we going to find Betty in patient 0? Okay. So if we find her, we say, I found Betty. If we don't, we print, I didn't find Betty. What do we think is going to happen? Are we going to find Fred? Are we going to find Betty? Okay. Oh, print. Lakeland is located at index patient 0 dot index. So that should tell us which spot Lakeland is at, right? Because, by the way, Fred lives in Lakeland. And real quick question, where do we think Lakeland's going to be located at? 4? Okay. Uh-oh. Sadly, red code. Let's take a look at what's going on here. So first off, let's focus on the positive. Did we find Fred?
Yeah.
Did we find Betty?
Yeah.
Is that what we expected to have happen? Okay. What's going on here?
So you want to follow that one line, go print, and then we can enter blank on our runner, case sensitive or not.
And the answer is?
It is. Yay. Case sensitive.
Ah, so Lakeland is located where?
In the core.
So we were able to search the list for a particular string. We found it, and we were actually able to get to report back to us what the string was, right? All right, well, this is great. I love adding stuff. I love finding stuff, but eventually, sometimes it's time for things to just go away. Okay? I'm going to make my list a little bit smaller. Okay? I know. Couple of different ways to do this. Okay? One way is to pop it off. We've talked about this one before. So here's my list: Harry, Cindy, Emily, Bob, Carrie, and Bill. Fantastic, wonderful. Time to pop them. We can use pop, but we can use a specific index. So Harry's at what location? Who's at? Cindy's at location what? 1. All right, time for Cindy to go. If we do a pop 1, right? See you, Cindy. Okay? Now, we call friends with pop, parentheses with nothing in between it. It takes the last item on the list. In this particular case, Bill hits the highway. We do that. So pop's one way to do it. Another way to do it is to use remove. And remove says, listen, I have no idea where this string's located. I don't have a clue. But I do know that it's in there someplace. So go find Carrie somewhere in your list and remove her. Boop. And she'll be gone. Life is hard.
Remove all your friends.
You're talking about removing friends reminds me of one of the saddest stories I've ever heard. So Yahoo was doing Yank layoffs once upon a time, and at Yahoo, if you worked there, you always had the Yahoo Messenger. Yahoo Messenger had a list of all the people that you interacted with, or the Yahoo employees. So they would call people into the manager's office and say, hey, listen, we appreciate what you're doing some layoffs, and unfortunately, anything came up because it's time for you to leave. The person would be very sad, and they would leave, but they would also call IT at that point in time and say, this person is no longer an employee, please turn off our IT account. So they would shut off all computer access for that person. But when they did that, what it meant was also the person was removed from the Yahoo Messenger system. So if you had a list of people up on your screen as to who you could Yahoo Messenger with, what was happening during the course of the day, it's just people who were in that list. It's like, yeah, oh wow. Welcome to the 21st century where you find out what's going on by your messenger list, right? Alright. So let's take a look at what we're doing. We're doing pops and removes. Alright, so we got all that stuff up there. I don't care about that. Remove the zombie yes or no answer from patient 0. So patients, patient ID, pop, friend. So zombie thing. Here, let's take a quick look to where that was located. So the zombie yes or no question is located at what position? The last one. 10. The last one, right? So it's at the tail end of the list. So if we want to get rid of it, we're saying all we have to do is do a pop, friend with nothing in between it. It'll just remove whatever the last thing on our list is. Okay, that's cool. Okay, so we'll print out the contents just to show that we got rid of it. Then we want to remove the first name from patient 0. So patients, patient ID, which is 0, pop 1. So whatever stored in location number 1 is out of there, right? And then we'll go ahead and we'll print out the list one more time just to make sure that we actually were successful in doing that. Okay, let's take a look at what we got here. So it's off the screen, but we know what that is. That's the standard sort of list. Oh, here we go. Now what we're going to do, we're going to pop off the zombie vector, right? So how many items do we have on our list now? How many did we have? Last one was no. Is it gone? Yeah, all right. Now the next thing we're going to do is we're going to get rid of whatever was in location number 1. So what's in location number 1? Fred. Down here, Johnson, no. Oh wait, does it look like Fred's missing?
Yeah.
And how many items are on the list? And how many used to be on the list? Okay, so it looks like that worked pretty well, right? Woo-hoo. Alright, so we can add things, we can remove things, we can find things. What is left? It seems like we've done everything. Oh, concatenation and replication. Okay, so what we're going to do here, we can stick lists together like a car accident. You can have a list over here and a list over here, and if you bring them together, congratulations, you now have a single monster list that contains the contents of both of those. So if I have my friends, Fritz and Cindy, and your friends, Lee, Pat, and Nafung, then what we can do is our friends is my friends plus your friends. Pretty cool how that one works. If you want to concatenate the same list multiple times, use the replication operator star. So basically, you can multiply a list by a number, and it takes all the contents of the list and does it over and over again. So we can do 1, 2, 3 multiplied by 4, and we end up with 4 sets of 1, 2, 3. How many? So this is for like months or something like that. We want to set everything to an initial value. Let's take a look at our code and see what we got going on there. Print it all out, don't care about that. Add the patient's age and the encrypted social security number to the patient record. So patients, patient ID equals patients, patient ID plus square bracket 32 and a string square bracket. All right, so it looks like we're going to take a list and we're going to add it to a list. All right, that's pretty cool. Then we'll print it out, make sure we did it. Add the word zombie to the patient's record 5 times. So patients, patient ID equals patients, patient ID plus square bracket, zombie string, square bracket, times 5. Let's see if this works. So we print it out and everything's lovely and fine, and then we come here, wait, no, we print it up there. Then we came along, what did we do here? We added 2 things, right? Age, and also the encrypted social security number, right? So we tacked on 2 things, so that worked out. So adding a list to a list seems to work pretty well. Then we go down here, now there's 12 items there. We go down here, oh, we got the original 12. Then we said we wanted to add zombie 5 times. And did it work? 1. Yes. 5 zombies have been added to Fred Johnson. Fantastic.
That sounds horrifying.
Alright, I think we got one more to do here. Oh, equality test. Use the equal operator to compare whether or not 2 lists have the same elements. Alright, that sounds like a fair deal. Okay? So if I had 149 and I did equal 149, should it come back true or false? 149 is 149, right? But if I did 149 to 419, I mean all the digits are there, right? Does position matter? It does. And the opposite, obviously, of equal is exclamation mark equal. This is not equal. The expression 149 not equal to 49, that is a true statement. I think I got one more thing to code here. Alright, let's see what we got going on there. So we print it out like we've always done. If patients, square bracket 1 equals patient square bracket 2, then print out patient record 1 and patient record 2 are identical. Otherwise, print out patient record 1 and patient record 2 are not identical. What would we expect the answer to that be? False. Right? Because Fred Johnson and what, Betty Williams or something like that are the first 2. Okay. Now we're going to say new patient equals. We're going to use a new command that you'll learn in just a minute or 2. List of patient 0, which is basically copying the contents of patient 0 over into new patient. Okay, so we just copied it. If new patient equal patient 0, then print new patient record and patient record 0 are identical. Else print that they're not equal. What would we expect to occur there? We just made a complete copy of patient 0 and stuck it in new patient. We think they're gonna be equal, right? Same dang thing, right? We just copied it. My goodness gracious, right? Well, let's give it a run. This is what we got. Poof. All right, so we print out everybody. Yay! Patient record 1 and patient record 2 are not identical. Fred Johnson is not equal to Betty Williams. No rocket science breakthrough there. New patient record and patient record 0 are identical, which is actually what we expected because we made a copy of patient 0 record, patient 0 record, and we stuck it into new record. So that's exactly what we anticipated. Sum, maximum and minimum, you can play all sorts of crazy games with lists once you got the stuff in there. You can actually do a sum of a list if the sum just contains numbers. If you have strings, this one's just going to die a horrible death. But if you have a string that contains like ages or baseball scores or currencies or whatever, and for whatever reason you decide you'd like to sum it up, all you have to do is put sum, paren, and the list name or the list contents in between the parentheses, and it will give you a single value that says, here's what it is. Okay? Arguably, if you put everybody's age onto a healthcare record, you could sum up everybody's age, and then you could divide it by the number of records, and you could come out with the average age of your patients. I don't know if that's valuable, but you can do it. You can also do max and min. Once again, it has to be max and min will actually work on either strings or numbers, although it has to be consistent. It has to be all strings or all numbers. If it's numbers, we know exactly what max and min are. There's no question about that. But if it's a string, it does it alphabetically. So min of Fred, Ann, and Sue comes out to be and the reason is because A occurs before either F or S. And by the way, if you got a bunch of stuff by A, we look at the second letter, third letter, fourth letter, so these are additional methods that you have available. Some max and min. Yes, you could. You could, and then you could actually remove that name from the list, and you can find the next first, and the next first, and the next first, until the list is all gone. Right? You can eat the list, so to speak, right? That would actually be one way to do it. Very quickly or close to a bubble sort. Actually, a selection sort, right? Where you pick out the minimum, you work it. But once you pick it out, great, I've got the minimum now, but I've got all the other minimums that I found. So now I have to take the minimum, I have to work the minimum into my list of previous minimums, right? That is the selection sort right there. That's all it does, okay? What happens when you copy a list? We talked about this last time, I just want to reiterate it. If you said scores equals values or something like that, in the world of Python, this is very, very Python unique, what's going to happen is it's just going to set the memory location pointer to be the same thing. So it doesn't actually make another copy of whatever that list is. It's just going to make the pointer that goes to that memory location to be the same thing. What it means is if you go to the list and you make a change to that list, both values and both scores are going to reflect that change. Which becomes a very big deal for you if you're trying to make a backup of your list or something like that. You don't want to say values equal scores or scores equals values, because that's not going to get you what you want. Instead, what you want to do is you want to say new list equals list, print the value, the list that you're trying to copy. Okay? So in Python, if you want to make a completely separate version of a list, you have to use the list statement to make it happen. Now, once you do that, then all of a sudden, values and prices now will refer to a different list, which is exactly potentially what you want to have happen. Interesting enough, the list function can be used to turn something that's not a list into a list. So if you have something that's a sequence of stuff, like a string, you could list it up, and then what it'll do is it'll produce a list that consists of a list of all the characters in the string. So it would convert basically a string to list, is what you can do. Not sure why that's valuable, but it's always good to have in your back pocket. All right, so what did we cover today? We talked a lot about what you can do with lists in Python, right? We talked about appending, we talked about inserting, we talked about finding, removing, and concatenating. Somewhere, some of this stuff must be valuable to you as far as your homework number 2 is. All right, just kick it around. Pretty easy stuff. It's not that hard. It's just you have to remember that it exists. Whatever shall we do next time? More lists, but more importantly, list algorithms. How to do stuff with lists. You get the impression that lists might be sort of important by some? Fantastic, we will get together again next week. Have a great weekend, guys.